Hello. So today in this video, I'll solve two questions basically. One problem is based on rocket repulsion and another one is based on a balloon problem. And these questions are very important problems. Similar questions comes in your NEET exam. These questions also came in the previous year NEET exam. So the question is, a 5,000 kg rocket, a 5,000 kg rocket is set for vertical firing. The exhaust speed is 800 meters per second to give an inertial upward acceleration of 20 meters per second. So the question says that the rocket is there, and in this rocket, the mass of this rocket is 5,000 kg. It's set for vertical firing, and the exhaust speed, that means the fuel inside from the rocket, which is exhausting at a speed of, that will say u is equal to 800 meters per second. If you know the derivations, or we can derive this, I can derive this for you. So to give an inertial upward acceleration of 20 meters per second, the amount of gas ejected per second to supply the needed thrust will be, okay. So we'll get an equation basically, you see. So the equation is, let me derive. So suppose this is the initial case. This is the rocket, which is just initial condition. And let's say the rocket started with a velocity v. Then after some time, the rocket will have, let's say the velocity increases, let's say v plus delta v. But in this time, the liquid or the fuel which is inside the rocket will be decreased. So the mass of the rocket will decrease to m minus, let's say delta m. And the fuel which is coming out, let's say with a speed u with respect to the rocket. Now someone standing, one observer, if it is standing, what you will observe? You will observe that the speed is, you will observe the speed is v minus u, okay, because the rocket is going up with a velocity v and the fuel is coming with u. So what the observer outside will observe? He will observe a net velocity of this one. So the net velocity of the fuel, exhaust fuel, is v minus u, he will observe, okay. So, and the mass is, because delta m mass is reducing from the rocket after the time, and here the time is, let's say t, here the time is t plus delta t, okay. Then from conservation of momentum, we can write that the initial momentum is mv is equal to the total momentum after time t must be equal. So after time t, the total momentum is m of rocket becomes m minus delta m, and the speed of the rocket is v plus delta v. So mv plus, so delta m is coming downward, okay, delta m is coming downward, the fuel So delta m into v minus u. So this is your equation. So from here you can write mv is equal to, just multiply mv plus m delta v minus b delta m minus delta m delta v. Very small quantity delta m is changing and delta v, so we can change in velocity will also be very small. So we'll consider this is 0 approximately, plus v mu minus u delta m. Okay, v delta m minus plus cancelled out. So what will remain? So the remaining terms will be, mb will come cancelled out. So the terms will remain is 0 is equal to mdv minus udm, or you can write mdv is equal to u delta m. So this relationship is very important. Now you can do one thing. You can find out the rate of change of, you can divide a delta t, so you can get a rate of change of this mass or this velocity. You can do one relationship. So m delta v by delta t is equal to u delta m by delta t. Okay. So this is very important relationship. Now, as delta m will be what? Final mass minus initial mass, but final mass is less because the mass of the rocket is decreasing. So you will get a delta m negative if we'll use it in the derivative form. So you can write that, and dv by dt is what? So you can write m dv by dt if the change is happening very minutely or constantly. We can differentiate. We can write in terms of dv by dt, and this is u minus dm by dt. You can write. Okay, this is the rate of change of your mass of the rocket. Or dv by dt is known to us. This is acceleration. So ma is minus u dm by dt. So this relationship is very important relationship. Okay, and so this is this ma is mass into acceleration, or this is the thrust, the force on the rocket. Thrust, or you can say force, that is ma is equal to minus u dm by dt. Okay. So this is the relationship. Now what we can do, now we have the relationship, right? We got the relationship. So we'll solve this problem. So now let's solve this problem. So here in the problem, we'll use this formula, and we'll use also the free body diagram also, because here the case is slightly different than the equation we have derived. Okay. So now the case is 5,000 kg rocket. So this is your rocket of 5,000 kg. So it's set for vertical firing. The exhaust speed, as we can see, exhaust speed is u, that is 800 meter per second to give an inertial upward acceleration 20 meter per second. So acceleration is given 20 meter per second. Now negative second square. The amount of gas ejected per second. That means the question is asked that about dm by dt is what? Okay. So now when it is set for vertical firing means we'll find out the initial case. So at the initial case, the rocket will have a upward thrust which is equal to u dm by dt. Okay, and it will have also, due to the mass of this rocket, there will be a downward force, that is mg mg. Okay. So we can write an equation that t is going upward, means ultimately it will move with an acceleration a. So this thrust, upward thrust, minus your weight of your rocket is equal to m0a. This is a net force. Thrust is this much. Okay, initially the thrust is this much, and the downward direction force is weight due to the weight. It's m0g. Now you can write that t is equal to, you got that, no? U dm upon dt minus m0g equal to m0. Okay, or you can write that acceleration is equal to u by m0 dm by dt minus g. So this is the case of initial acceleration. Okay, so initially when the rocket is just set to fire, set for the vertical firing, at that case the acceleration will be, that will call initial acceleration, and we can write this in this form. So using this equation, you can now put all these parameters and you can calculate. You can calculate them. Okay. So here you can calculate that your u a is equal to, u is given, right, 800, m0 is 5000, dm by dt you are supposed to calculate, minus g is 10. Acha, a is also given, so you can put the a here. You can put the a, that is 20. Now you can find out dm by dt. Bring 10 to the left side. 30 is equal to, this cut zeros, 8 by 50 dm by dt. Dm by dt is the amount of gas ejected per second. So dm by dt is equal to, cross multiplication, 30 into 50 by 8, 4. 15 to 25. So this is 250, 375 by 2. So 2 1 2 7 2 8 just 16, 1 5 7 4 5. Unit is what? Mass is kg. So kg second inverse. So what is the option? 187.5 kg per second. B is the answer. Okay. So in this way, you can solve the rocket problem. It's very you should just keep in mind few parameters. What is U? What is the thrust? Okay, so that you can easily solve these questions. Okay, thank you. Let's stop here. You can join the WhatsApp and Telegram group for JEE and NEET problems. I keep on solving these problems and also give some new problems in the group. So you can join the group for more practice. Thank you.